Okay, when you multiply two numbers together and you got to come up with another number as a result, the numbers you multiply are called the factors. So if you say 2 times 3 equals 6, these are the factors and this is the product, all right? So when you multiply factors together, the number you get is called a product, and these are the factors. Now what if I started with 6? I wanted to say, what times what would give me 6? And if I recognize that 2 times 3 gives me 6, this is a way of breaking it down. And notice that neither 2 nor 3 will break down any further. There are no pairs of numbers that will multiply to give you 3 other than itself and 1. But if I did 3 times 1, well, I could do 3 times 1 again, and I could do 1 times 1, and I could keep going forever. Okay, so once I get down to something where nothing will break down other than itself and 1, then we're done. So this is called a prime number. So I'm going to eliminate all this, and what we have here are called the prime factors. Okay, let's go back up here and factor 12 and 7 here. Okay, so 12 breaks down to something times something. So you might say, well, 2 times 6, or you might say 3 times 4. Let's do it both ways and compare the results. So what if I said 2 times 6? Look at the 2 and look at the 6. 2 is prime, it won't break down any further. 6 breaks down to 2 times 3. So now we're down to prime factors. None of these will break down any further. So 12 is equal to 2 times 2 times 3. Right there, okay? So what if I had done this a different way? Instead of 2 times 6, what if I went 12 is 3 times 4? Okay, notice 4 breaks down to 2 times 2, and now we're down to prime factors. 2, 2, 3, 2, 2, 3. Same prime factors. It turns out it doesn't matter what route you take to get there. If you take a number and you break it down into factors and you break those down until you get to prime factors, there's a unique prime factorization of this number. Whichever way you break this down, you can keep going and you can break it all the way down and you'll get the same result as though you did it any other way. What about 7? Can I break down 7? Well, 2 doesn't divide into it evenly. 3 doesn't. 4 doesn't. 5 doesn't. 6 doesn't. Nothing will except itself and 1. Okay? So 7 times 1, but that doesn't really break it down. It just leaves it where it is. So you can't break 7 down into factors, and so we say this is prime. Okay? And we can say these numbers here are prime as well. Okay? So if a number will not factor, it's prime. If a number will factor, you break it down until all the factors are prime, and we're done. Okay? So this is a useful technique when we're doing things like canceling fractions, when we're adding fractions, when we're doing all kinds of things. So it's an important skill. Let's look at a couple of bigger numbers. How would we break down 18? So all you have to do is think of a pair of numbers. When you multiply them, it gets 18. So you might say 2 times 9. You might think of 3 times 6. Doesn't really matter. Let's go 3 times 6. Break down the 6 to 2 times 3. And we're done. These are all prime factors now. So this is 2 times 3 times 3. What if we had done it 2 times 9 instead? I could have 2 times 9. 9 is 3 times 3. Again, 2 times 3 times 3. Same result either way. How about 24? 24, you can think of 2 times 12. You can take 6 times 4 is 24. 3 times 8 is 24. Any of those will work. Let's go 6 times 4. Okay. 6 is 2 times 3. 4 is 2 times 2. And notice all of these are prime factors, so we're done. So what do we have? We have 2, 2, 2, and 3. Okay? Now, before we quit here, notice that all the factors of 24 can be built up from these prime factors. So for instance, if I look at the pair of 2's here, that's a 4, and 3 times 2 is 6. If I look at the 3 2's, it's 2 times 2 is 4 times 2 is 8. Here's 3 times 8 is 24. If I look at the 2 times 2 times 3, that's 4 times 3 is 12. Here's 2 times 12 is 24. So all the different possible factors can be built up from these prime factors. Same thing over here. Here's a 6 times 3. 2 times 3 is a 6. And here's a 3. Or I could take 3 times 3 is 9 times 2 is 18. Okay. Okay, I'd like to apply factoring to a couple of other ideas here. And these are techniques that are used in a lot of different areas in mathematics. And factoring is the key to being able to do these. The first is to find the greatest common factor of two numbers. So if I want to find the greatest common factor of 18 and 24, what I'm looking for is what's the biggest number that will divide into both 18 and 24. Okay, so if I think of a number that's the biggest possible number that will divide into both of them, what I'm looking for is the number that has the most factors possible from the list of factors of these two numbers. If I can put together the biggest possible list of factors that's contained within 24 and also 18, that'll be the number I'm looking for. So look at the two lists of factors. So let's start with the 2's and say, how many 2's do I have available to construct this number? Okay. Well, there's 3 of them here, but there's only 1 of them here. We're looking for common factors. So I want to look for something that's in here that's also in here. The most 2's I can use is 1 because there's only 1 2 in 18. So I'm going to write down a 2. How about 3's? This one has 3 times 3. This one only has a single 3. So the greatest number of 3's that I can use is just 1 of them. Okay? And so that's it. If I take 2 times 3, that is a part of this list. It's also a part of this list. And I've used each of these prime factors as many times as I can and still have it be part of both lists. Okay? So this is 3 times 2 is 6. And notice 6 will divide evenly into 18. 3 times 6 is 18. And 6 will divide into 24. 6 times 4 is 24. And it's the biggest number that will divide into both of them. And so that's the greatest common factor. So the key is look at the factors, find a list of factors that's contained in both of these, and that's going to be how you find the greatest common factor. Okay, now we come to a related idea, which is called the least common multiple. Okay, and the least common multiple is a number that's a multiple of both of these numbers, but it's the smallest number that's a multiple of both of those numbers. All right, so let's start with 18 and 24 again. And I want to find a number that contains all the factors that are in 18 and enough extra factors so it's also a multiple of 24, but not more factors than needed. Okay, so let's start with one of these lists. How about 18? So if I start with 2 times 3 times 3, it has to have those factors in it for 18 to be able to divide into it, since that is 18 right there. What else do I need? Well, this has 3 2's. I only have 1 2 shown, so I need 2 more 2's. Okay. This has a 3, but that already has at least 1 3, so we're done. So here's what we have. 2 times 2 times 2 times 3 times 3. 2 times 2 is 4 times 2 is 8. 3 times 3 is 9. 9 times 8 is 72. So it looks like this is 72. Will both of these go into 72? Well, let's prove that it does without having to do long division. Let's look for 18 in all this list of factors. 9 times 2 is 18, so there's 18 right there. And so this is 18 times 4. So if I go 18 times 4, that should be 72. Work it out, you'll see that it works. How about 24? Let's see, 24 is 6 times 4. Okay, so here's 6, and here's 4. So 6 times 4 is 24. It looks like 24 times 3 should give us 72. Okay, I'm going to leave these to you. Work out 18 times 4. Work out 24 times 3. I think you'll get 72 in both cases. So 72 is a multiple of 18. 72 is a multiple of 24. and I didn't use any extra factors besides just the bare minimum needed, so it's the least common multiple. Okay, here's a little diagram to show the relationship between the least common multiple and the greatest common factor. If I have my 18 and my 24 here, there's a number down here that will divide into both of them. So it is a factor of each of these. In fact, it's the greatest common factor of these, and that number is 6. And so this is the greatest common factor. Okay? It is a factor of 18, it's a factor of 24. The least common multiple is up here. The 18 is a factor of this number, and 24 is a factor of this number. And we saw that that number is 72. So this one is the least common multiple. So the greatest common factor will divide into both of these, and it's the greatest number that will divide into both of these. The least common multiple is the least number that's a multiple of 18. It's also a multiple of 24. So this is always going to be a number smaller than these numbers here. And this number is always a number that's going to be bigger than these numbers here. And that's the way this works. So here's the two factors we're starting with. Here's the greatest common factor and the least common multiple. Okay, factoring numbers is a basic skill. You're going to see a lot more things about factoring as you go through math. This is just getting started with the basics here. Okay, so given a number, if it can be factored, factor it to prime factors. If it can't be factored, it's already prime. And that's the basic thing you need to know right here.